In this video, we're going to be discussing how to analyze the factored form of a polynomial and write a polynomial function from its zeros and its linear factors. So first, let's discuss what a polynomial factor is. Well, in the past, we have discussed when you have a constant, you can find its factors. You're thinking of numbers that multiply together that will get you 6. So in this case, 2 and 3 would be considered prime factors. Same thing applies to a quadratic or even a polynomial. So the linear factors of this quadratic would be x minus 4 and x minus 2, because if you were to FOIL these together, you would get back the polynomial. So these are what you would consider linear factors of this function. So the first step you do when factoring polynomials is always look for what is in common. In the past, we have discussed this as being the GCF, or the greatest common factor. So when you look at this polynomial, you want to know what can you factor out that is in common. Well, I noticed that there is a 3 that can be factored out of the coefficients. So I'm going to factor out a 3. I also noticed that there's x's in both terms. There's 7 x's here, but here there are only 2 x's. So I can only pull out the minimum number of x's. I factored out my 3, so I do not have a 3 here. I had 7 x's, but I only pulled out 2 of them. So if I factored out 2, that means I have 5 left, because 2 plus 5 gives me 7. And then I factored out the entire x squared, and then I also factored out a 3, and 12 divided by 3 gives me a 4. And that is how you would factor that polynomial. In this case, I noticed that there is a 4 that is in common. So if I factor out a 4, I'll be left with x squared minus 7x minus 18. Now, I actually am not done, because I notice that this can also be factored. So I'm going to bring down my 4, and then I notice that I can figure out what multiplies to give me 18 and adds or subtracts to give me negative 7. And the answer is going to be a negative 9 and a positive 2. Because negative 9 plus 2 give me a negative 7, and they multiply give me negative 18. So x minus 9 and then x plus 2. And this would be my finished or final completed factoring of this polynomial. Now, there's also things that are called special factors that have been discussed in the past, that anytime you have a number in front and you cannot factor it out completely like we did here. We had a number in front, but we were able to factor it out. If you have a number in front that cannot be factored out, you would perform the illegal move. So just as a recap, to do the illegal move is step 1, multiply the first times last. 3 times 2 is 6. Take the middle number just like normal. So what multiplies to give me 6, but adds to give me a negative 7? And the answer is going to be negative 6 and negative 1. And so we would write those factors, x minus 6 and x minus 1. However, we are not done. We now have to undo what we did at the beginning. Where we multiplied by 3 at the beginning to get 6, we now need to undo that. And so we now divide by 3 in the end, and we're going to simplify. 6 divided by 3 is 2. This does not simplify, and so I'm going to bring the 3 to the front of the x, and that will be the way you would completely factor when their coefficient is not 1 in the front. We've also discussed the difference of squares, which we have talked about in the past. Is like if you have x squared minus 9, then it can factor into x minus 3, x plus 3. You can do the same thing with any even exponent, actually. So if I can figure out what I can take out of this to make it squared, and what to take out of this expression to make it squared, I can put it into this form. So what squared will give me a 9? And the answer is 3, because 3 squared gives me 9. And then what squared gives me 4? It is x squared, because x squared will give me x to the 4th power. And then over here, what squared will give me 25? And the answer is 5, because 5 squared is 25. And then y, because y squared gives me y squared. So now that I have my two terms that are now a part of the difference of squares, I found two things that are squared. I can now place them into the formula. So it will be 3x squared in the first, and then 5y in the second. Again, you are taking the term on the inside that would be squared is what you're going to put in. For example, the x squared minus 9 again. This would have been x that was squared, and this would have been the 3, because 3 squared give me 9. And so x goes in the front and 3 goes in the back. Same thing applies to any term that can be squared and any exponent that is even. Finding zeros. Okay, so we are going to use the zero product property to find values that will make the polynomial equal to 0. Meaning, if x minus a is a linear factor of a polynomial, then x equals a is a 0. Meaning, if x minus 3 is a linear factor because it is being multiplied by other factors, that means I can set this equal to 0 and solve, which means I would add 3 to both sides. That means x equals 3 is a 0. Same thing, if x plus 4 is a linear factor, then set it equal to 0, and you'll get x equals negative 4 would become a 0. Same thing with x minus 1. You would set it equal to 0, so x equals 1 would become a 0. So therefore, the zeros of this polynomial would be 3, negative 4, and 1 would be the zeros of this polynomial. So here's how you would go from the very beginning of a polynomial. You would factor it, and then you would take each factor, set it equal to 0, and then you'll be able to actually solve for all the factors. So, for example, always see if there's anything in common. There is. You can actually pull out an x. And if you factor an x out, you'll be left with x squared minus 10x minus 24. So I'm going to bring down the x, and then this also will factor. So you want to know what multiplies to give you negative 24, but adds to give you negative 10. Negative 24 and negative 10. Well, negative 6 and negative 4 give you negative 10, but that will give you a positive 24, so that wouldn't work. Negative 12 and 2 will work. Negative 12 plus 2 will give you negative 10, but negative 12 times 2 gives you negative 24. So it'd be x minus 12 and x plus 2. Now that we have our factors, so these are our factors, x minus 12, and x plus 2. Now, to find the zeros, I'm going to take each of these and set it equal to 0. So therefore, we have 0 as a factor. We have 12 as a factor because you would add 12 to both sides. And we would have negative 2 as a factor because you would subtract 2 on both sides. So you would write that the zeros are 0, 12, and negative 2 as your final answer. Multiplicities is when a linear factor is repeated. And if a linear factor is repeated, then the 0 is repeated, and it would be called a multiple 0 or a multiplicity. So for example, this basically can be written as y equals x plus 5 times x plus 5 times x minus 4. Those are the three linear factors. So x plus 5 equals 0, x plus 5 equals 0, and then x minus 4 equals 0. So therefore, x would equal negative 5, x again would equal negative 5, and then x would equal a positive 4. So the way you would write this, there's two ways to write it. You could either say that the zeros are negative 5, and 4, or the way you're going to see it written and the way you need to write it is the fact that you're going to say that the zeros are negative 5 with the multiplicity of 2. Why 2? Because it repeated twice, hence the exponent 2. And then the other 0 is a 4. So if anything is repeated, you're going to just write that number once and then tell me what the multiplicity is of that number. So for example, in this case, we first need to figure out if there's anything that is in common. So I notice that in every one of these terms, I can pull out an x cubed. If I do that, if I factor out 3 of these, then I'm left with 2. Here I'm left with 1. And then here I factored all 3 of the x to the third, so I'm left with just a 9. Now, this also factors, so I'm going to bring down the x cubed, and then this also factors into x minus 3, x minus 3. So you could actually write it as x cubed times x minus 3 squared. Why squared? Because there's 2 of them. So to actually find the zeros from these factors, then you would set this equal to 0 and set this equal to 0. So x will equal 0, but there's a multiplicity because it happened 3 times. And then you would set this equal to 0, but there was a multiplicity of 2 because there were 2 of these linear factors. And so this is what you would actually write as the final complete amount of zeros that you have. Now you can also write polynomials from zeros going backwards. So if I actually give you the zeros, I can actually figure out what the original polynomial would be. So the first, what we're going to do first is we're going to write the zeros as factors. So if you have a 0 of negative 2, that means x plus 2 would have been the factor. Remember, opposite sign basically is what happens. And then if 4 is a factor, then, if 4 is a 0, then x minus 4 is a factor. This set a multiplicity of 2, which means there were 2 zeros at 4. So you need to write the factor 4 first. And second step you would do is you now FOIL this in order to find the standard form of the polynomial. So if I FOIL this, I will get x squared minus 4x plus 2x minus 8, which will give me x squared minus 2x minus 8. Now I will bring down the last factor and I will FOIL these together. So x squared times x is x cubed. X squared times 4 is a negative 4x squared. Negative 2x times x is negative 2x squared. Negative 2 times 4 is a positive 8x. Negative 8 times x is negative 8x. And negative 8 times 4 is a positive 32. Now you need to combine like terms. There's only one x cubed, so you're going to bring that over. You have negative 4x squared and a negative 2x squared. That would give you a negative 6x squared. 8x and a negative 8x cancel each other, and then you're left with a positive 32 as your final answer. So to recap, the first thing we're going to do is we are going to factor this polynomial. Then we are going to deal with finding the zeros in any multiplicities, and then we're going to work backwards of writing the polynomial. So I'd like for you to attempt these problems, pause the video, and then when you're ready to see the answers, go ahead and click resume. Okay, to factor, you're looking for anything that is in common. Well, I'm going to go ahead and pull out a negative and a 2 because I noticed that they're all even, so I can pull out a number 2. And they all have an x, so I'm going to factor out an x. So when I pull out a negative 2 and an x, I'll be left with x squared. I'll be left with a positive x because I pulled out the negative and the 2. That's why it's turned positive. And then I'm left with a negative 20 because negative 2 times negative 20 give me a positive 40. Now, normally I would be done here, but I noticed that this also factors. So I'm just going to bring over the negative 2x that's in front. And then what multiplies to give me negative 20 but adds to give me 1? And the answer is going to be a positive 5 and a minus 4, because 5 minus 4 is 1, and then 5 times negative 4 is a negative 20. So this would be our final answer. Next, we're going to do the same thing, except we're then going to go one step further, and we're going to actually find the zeros. So first thing is, notice, is there anything in common? Well, there's x's in common, and I look for the smallest exponent, which is an x squared. That is what I can pull out. So I'll be left with 2x squared, 7x minus 4. Now I need to I need to factor what is on the inside. And because there's a number in front, I will have to use the illegal move. So I'm going to keep the x squared. I don't want to get rid of it. That just needs to stay in front. So illegal move. I multiply 2 times negative 4 to give me negative 8 and adds to give me 7. So 8 and negative 1 is going to be my answer. So it'd be x plus 8 and then x minus 1, because they subtract to give me 7, but they multiply to give me negative 8. But I illegally multiplied by 2 to get 8. So now I need to divide by 2. So I'm going to bring down the x squared. 8 divided by 2 is 4. This does not divide, so the 2 is going to get thrown in front. And now we want to find the zeros. So we're going to take each of these and set them equal to 0. So I have x equals 0 here. But don't forget, this is a multiplicity of 2 because it happened twice. I also get an x, a 0 at negative 4. And then I get an x at 1/2 because I would add 1 and then divide by 2. So these would be my zeros. So there was one multiplicity and that was at 0. Now here we're going to work backwards. The polynomial has a 0 at 0 and at 3, but there's a multiplicity there, which means you'll have x minus 0, and then you'll have x minus 3, but that happened twice, so you're going to write it twice. So don't forget, you take the opposite sign. If 3 was a 0, then x minus 3 was the factor. X minus 0 is just x. X minus 3 times x minus 3 is x squared minus 3x minus 3x plus 6, because negative times a negative. So I'll get x times x squared minus 6x plus 6. No, because it's not 6, it's 9. So sorry about that. Negative 3 times negative 3 is a positive 9. And so negative 6 plus 9. But you're not done. You now have to FOIL this x, or you have to distribute this x to the parentheses. So our final answer is going to be x cubed, x times x squared, minus 6x squared plus 9x will be our final polynomial with those zeros.